Welcome to The Explainer. If you've ever even dipped your toes into Python, you've used data types, probably without even thinking about it. They are the absolute bedrock of everything you build. So today, we're going to make sure you understand them inside and out.
So let's just dive right in with a simple question that gets right to the heart of it. How in the world does Python know that 50 is a number you can do math with, while hello world is text you can't? Well, the answer is all about something called data types.
And here's how we're going to tackle that. We'll start with the basic definition, then cover the simplest values you'll see. From there, we'll look at how Python groups data together, both in ordered sequences and unordered collections. And finally, we'll pull it all together to show you how to think of these as your own personal Python toolkit. All right, let's get started.
First things first, what exactly is a data type when we're talking about programming?
You know, the easiest way to think of a data type is just as a label. And this label tells Python two absolutely crucial things. First, what kind of information is inside a variable, and second, what you're actually allowed to do with it, right? You can add two numbers, but you can't divide two sentences. The data type is how Python knows the rules of the game.
Okay, so with that definition in mind, let's start with the most basic values you'll ever run into, numbers, and the simple but incredibly powerful idea of true or false. First up, we have integers, or int for short. These are just your straightforward whole numbers. No fractions, no decimals, just clean, simple numbers like 5 or -10 or 200. And you can always check this yourself. When we ask Python, hey, what type is our variable a? It tells us it belongs to the int class. This little confirmation is happening under the hood constantly while your code is running. Okay, so next up are floats. These are the numbers that do have a decimal point, representing what we think of as real numbers. So 5.0 is a float, just like 3.14 or -0.01. And here is where it gets really interesting. Even though 5 and 5.0 represent the exact same value to us humans, that tiny little decimal point makes all the difference to Python. It sees that dot and immediately classifies the variable as a completely different data type, a float. The final simple value is the boolean. It's the simplest of all, really, because it only has two possible values, true or false. That's it. But this simple type is the foundation of all logic and decision-making in your code. So, we've covered single values. But let's be real. What happens when we need to handle a whole collection of items, like a list of names or a series of steps? Well, that's where ordered sequences come into play. The crucial concept here, the main thing to remember, is that order matters. A lot. If you have a list of steps to bake a cake, the order is pretty critical, right? In a sequence, the first item you put in is always at position 0. The second is at 1, and so on. That position is locked in. So Python gives us three main ways to do this. We've got strings for text, which are really just sequences of characters. Then we have lists and tuples, which are these powerful collections that can hold all sorts of different data types mixed together. And you can spot them by their syntax: quotes for strings, square brackets for lists, and parentheses for tuples. Now this brings us to a really critical difference between lists and tuples: mutability. A list is mutable, which is just a fancy way of saying it's changeable. Think of a shopping list. You can add things, remove them, change your mind. A tuple, on the other hand, is immutable. It's like a locked box. Once it's created, its contents can never be changed. And this is actually great for data you want to protect, like coordinates or important settings.
Sequences are awesome when order is important. But what if it isn't? What if your main goal is to make sure every single item is unique, or to look things up by a custom label instead of a position number? For that, we need unordered collections.
This brings us to sets. Their defining feature, their absolute superpower, is that they automatically enforce uniqueness. You simply cannot have duplicate items inside a set, period. And check this out. If you try to create a set from a list that has a duplicate geeks in it, the set just automatically discards the extra one. Poof! You're left with a clean collection that only contains one of each unique item. It's incredibly useful. And finally, we have dictionaries. The best way to think of a dictionary is, well, like a real-world dictionary or maybe a filing cabinet. It doesn't store things by position, it stores a value that's associated with a unique key or a label. So, looking at this example,
You wouldn't ask for the item at position 1. That whole idea just doesn't apply here. Instead, you'd specifically ask for the value associated with the key name, and Python would instantly go and retrieve the value for. It's a super fast and intuitive way to handle labeled data.
Okay, deep breath. We've covered integers, floats, lists, sets, and dictionaries. That's a lot of different types. So how do you pull this all together and figure out which one to use when you're actually writing code?
The absolute best way to do it is to see them as a toolkit. Each data type is a specialized tool that's designed for a specific job. Need to do math? Grab an integer or a float. Need a flexible shopping list? A list is what you want. Need to store user settings with labels? A dictionary is perfect. Knowing which tool to pull out of the box is a huge step toward writing really smart, effective code. And this all points to a really powerful idea in Python. See, you're not just storing simple data. When you create a variable, you're creating an object. Think of it this way. When you create a list, you're not just getting a dumb box. You're getting a smart object that already knows how to do things, like sort itself, or count its own items, or add new ones. Each data type comes with its own set of built-in abilities. So remember, understanding these data types isn't just about memorizing a bunch of definitions. It's about knowing the tools you have available. Once you really know what's in your toolbox and which tool is right for the job, you can build almost anything. So the only question left is, what will you build first?